Hey guys, welcome. Yeah, so problem 16 here, and if you've done problem 10 or if you've looked at problem 10 of the same qualifying exam, then you know this is kind of getting repetitive a little bit. And so we got to employ the same strategy that we did in problem 10, which is we want to turn this to stuff about sign, so that we can use U substitution. And it's easy enough to do, right? Recall again the Pythagorean identity of trig: sine squared x plus cosine squared x is equal to 1, right? And from this, we can easily see that cosine squared x is equal to 1 minus sine squared x, right? And so we substitute for this cosine squared x with 1 minus sine squared x, and then move forward. Now, that would mean that we have 0 to pi over 2. I guess the fact that this is a definite integral has, something to play, right? So cosine x, and then divided by, and then it's 2 minus, and then cosine squared x, which we just said is 1 minus sine squared x, so 1 minus sine squared x, and then, yeah, dx, and this equals 0 to pi over 2, still cosine x in the numerator, and then divided by, look at the denominator. The denominator is 2 minus 1, and that's 1. And then when we distribute this minus sign over here, we're just going to get plus sine squared x. So we get 1 plus sine squared x. Okay. We didn't care for much except for that sine squared x, right? But yeah, okay, cool. All right, so now we do U substitution as the best way forward, and so that's U equals sine x, and du then will have to equal cos x dx, and notice that this entire numerator is just du, right? Okay, cool. So we go, our integral is now equal to du, we just said the numerator is du, right? And then the denominator is like 1 plus 1 plus u squared, right? And you know that I love the arctan integral, and I swear by it. So clearly this is going to be arctan of u, this integral. But wait, we abandoned the limits, so we need to get back, right? Well, since u is equal to sine x, the lower limit, this is going to turn into sine of 0, because x is 0, right? We just got to plug in 0 right there. So the bottom limit is sine of 0, which is 0. And then the upper limit is sine of pi over 2, and that's 1, right? So this is our integral. And as we said, the integral without the limits would have been arctan u plus c, and so now it's arctan u evaluated at 0 and 1, right? And so this means arctan, by the evaluation theorem, this means arctan of 1 minus arctan of 0, right? Okay, cool. Well, what's arctan of 1? So we're trying to think of an angle whose tangent is 1. So the opposite and adjacent sides need to be the same. Wait, that's a 45-degree angle, so that's pi over 4. And then arctan of 0 is 0, however you'd like to think about it. So pi over 4 minus 0 is pi over 4, the correct and final answer. Yeah? Cool. All right, keep watching.